Okay, so we're getting towards the final stages now of manufacturing the helmet. The difference to what you've seen previously is I've actually coated this and built up some of the areas with Isopan, which is car body filler. I'll quickly show you there. Car body filler, it's basically a paste that you mix with a hardener, the same hardener that you use for peroxide to make the resin go off for the fiberglass. And you can also see some of the things that I tend to use, old bank cards or top-up cards. These are ideal, really. They're a cheap alternative to the stuff we can buy to give you a smooth edge as you apply it, and that saves a hell of a lot of time sanding down using something like this. You can always use a side of washing up liquid bottles if you cut the washing up liquid bottles, and then they're completely disposable. And that's just a quick way of applying a flat surface using the Isopan. Any small imperfections, I've just used normal filler that you would use in the wall. Stuff like that, but that takes a while to go off, so be very careful with that, and 9 times out of 10 it's not waterproof, so be sure to pick one that actually is waterproof and that avoids cracking and shrinking when the water evaporates out of it and it solidifies. Next stage then, once I've done that, was to apply a spray filler on it, and you can see the colour match between the two. So what I've done is use this is Halford's filler primer. It's about £8 a tin. It's worth its weight in gold though, because all the small imperfections that you would normally get that you would have to rub down, this tends to fill in quite well. So this is a good product that you could use, and it also primes the product ready to actually spray the final coat on. And that's where it is really. Now I didn't show too much of that simply because there's loads of things on YouTube. If you log onto YouTube, that'll actually show you how to use or do car body repairs, and it's the same process really. When you come to sand it down, there's various things you can use. You can use the aluminium oxide paper, you can use normal glass paper. You can see it's normal glass paper, it doesn't take much as well. This was to P120 onto this one. The higher the number, the smoother the actual glass paper or abrasive paper is that you're using. So 120 is fairly aggressive to sand down initially, and then I'll finish that off by smoother paper, and this is wet and dry paper actually, so it's water carbide paper that you use, again what you use to sand down cars. This is a 400 really. I certainly wouldn't be using anything less than 400. You can get 600, you can get everything up to 1200 to be honest, but it just depends on the sort of finish you need, but that's more than appropriate. So at the same time of buying the spray filler, I just went and got me some P400 to wet and dry the paint down afterwards, which left me with an absolutely perfect helmet until we had a bit of a problem, because this morning my iridium mask appeared and the visor to go into the helmet, and it doesn't fit. So what I had to do then is I've taped the visor in, and you can see I've already started to re-fiberglass the edge, which means I've got to sand all this bit back down again, but it's going to be worth it in fairness. So just to make sure that the visor fits across the top, etc. Now I will be siliconing some of it in as well as using some foam round, but it is important that the helmet and the visor joins together, because that's what's going to give it part of its strength, if I'm honest, so that's quite important as well. Now there is a few other points I would point out with the helmet. Obviously in hindsight it was probably better to have got the visor first before I started fiberglassing, to make sure the visor fitted in. So what I will do next time, if I ever make another one, is I will get the visor first and then do the fiberglassing, and then I won't have to correct the helmet. But you know, that's the way it goes. When life gives you lemons, you make lemonade, and we just have to move on and readdress it with this bit. Right, okay, so this bit is also quite soft in here, so I've decided what I'm going to do with this bit is turn the helmet over. I'm actually going to block off that bottom part, and I'm going to use a fiberglass sheet to do that. You can see I've got the bottoms ready to go, it's all ready to fit in, and once that edge is sealed, what I'll do then is simply just drill a hole through and spray it with expanding foam, the type that I would use in the products, for example on building sites, in between windows, etc. And although it's quite rigid, it's also quite lightweight, and that should make the helmet pretty tough at the front. Around the collars and around the bit that I've built up, obviously I need to fiberglass that back in and make that a bit stronger, and I might use some mesh here, some aluminium mesh, or put some corrugations in just to make this stronger, because this does have to be quite strong onto this part. So you can see I've already got the pieces cut out as normal. We always prepare our fiberglass cuttings ready to go, and there's quite a bit to do there, and once I've fiberglassed it, that is going to pretty much be the last part of it, and then I'll just sand it back down and add the things ready to apply the final coat. You can see I've got around the collar here, it's a bit ragged, and what I am going to try and do there is put like a car door sealing sort of type of material around so it doesn't hurt when you put them on, etc. And that's before we pad out the inside of the hat. So like I say, we're probably about 50-60% manufactured now. We've just got the electronics to sort out, put the visor in, finish the spray and distress it, and pad out the inside of the hat. And that's where we're at the moment. Just be mindful when you're using things like this, although it is glass reinforced plastic that we're using here, and the resin actually does make it quite strong. The resin also puts quite a lot of carbon into this, and it's important we understand about materials. The harder we make things, the more brittle they actually become. And we're not just talking about bending metals and work hardening stuff, it's about the chemicals that we put in them. As you add carbon to it, generally it makes the product a bit more brittler, so we need to look at putting a mesh on here, or indeed perhaps corrugating it with some sort of tubes, etc. when we build them in. Simple reason, obviously, like I say, you add carbon into it, it becomes more brittle. A simple example is glass itself. Bear in mind this is glass reinforced plastic. Glass is a very, very hard material. It's very hard to cut it, it's very hard to scratch it. However, if you apply a load to it, be it static or dynamic, obviously the glass, just even thermal conductivity for that matter, doesn't respond very well to that. It certainly expands, it certainly contracts, but it does shatter. So any sort of load, it will shatter, and that's the same with this, and that's why we need to make sure that's reinforced as well. Generally, while I'm working on the helmet, because it's all sanded down, ready to go, and some areas are smooth, you can see I'm actually working on a polystyrene bed, and that's just something I've placed on there just to protect some of the edges and the paintwork while I'm actually making the modifications. So that's it really. Like I say, in hindsight I would have perhaps put the visor in first before I got to this stage, but like I say, when life gives you lemons, you learn to make lemonade, and we'll take it from there. Okay, right, I'm going to have 20 minutes doing this, and we'll come back in 20 minutes time and see what it's like now.